Hello all, welcome to my YouTube channel PowerBud. Today I am going to show you IPC land pattern density levels. The density levels are used to gauge PCB footprint or land pattern designs with regard to how densely a board can be populated and with regard to the difficulty of trace routing and fabrication. Okay, so if you compare these two images, you can clearly distinguish the density level between these two images. For example, in the first image, you can see these four resistors placed in a minimum distance, right? You can see here they have added some clearance between the components here. And the traces are also not too close to each other. And for the second board, if you compare this capacitor resistor banks, they have kept very closer to each other. And the lines you can see here, the routing they have taken in a very tightly routed. For example, they have used very less space for the routing. So for the first board, the advantage is you will get enough clearance between the components. You can take enough space between the traces. So there is no limitation for the space. But the thing is, you are using more area. PCB area will be more. So that will add more cost to the PCB. But the signal strength, the signal quality, and the placement and all will be perfect for the first one. And when you compare to the second one, the advantage is you can design a compatible device with the second one. But the thing is, it is very difficult to solder these components, and also the routing will be difficult. So I hope you understand now the difference. So based on this density level, actually there are three density levels based on IPC 7351, that are density level A, density level B, and density level C. So in this image itself we can understand the difference between these three densities. So for the density level A, the largest courtyard and the least density. That means you have to keep the component in a bigger footprint. Make sure that it is having enough space for the soldering, and it should easy to solder. And for the second one, we are giving a medium level of land pattern. Component size we are not able to adjust, and we are only able to adjust the land pattern here. So that we have adjusted, we have reduced from this to this. And for the high density board, we have again reduced the component land pattern. You can see here it is very difficult to solder this kind of land pattern. So if I am placing a component over this land pattern, if I move this up or down, it would be difficult to solder, right? So for the density level A, largest courtyard and least density, as you can see here. And for the density level B, median courtyard and median density. And for the density level C, smallest courtyard and highest density. Okay. And why we need these density levels? For example, this is a classification based on how you are placing the components on a PCB. There is no strict rule that you have to follow density level A or C or something. But until if there is a definition, for example, if you have to develop a product, it should be compatible. For example, it should be portable or compatible device, then you have to go for high density board design technique. Then in that case you have to select density level C. Otherwise, if you are going to design an evaluation board, or if it is for the bench level testing, then you can go for the density level A. And if you have space, if you don't have that much space constraint, and somehow you have to reduce, or you have to check like both the quality and the placement, in that case you can go for the density level B. So for the density level A, you are actually what you are giving up. The thing is, for the density level A, you are not that much considering the price. You are considering the quality of the signal, the easiness of the routing, and also the easiness of the soldering technique. In density level B, you are considering both quality, and also you are considering the placement. So for the first case, the quality will be 80%, the placement technique will be 20%. And for the density level B, quality 50%, placement 50%. Density level C, quality will be around 70%, placement will and the sorry quality will be around 30%, placement will be around 70%. So you are more you have to more specify the placement in terms of when you are coming to design density level C. And there is no strict constraint that you have to follow density level A, B, C. You can follow something in between also. Like you can follow something lesser than density level C and greater than density level B. Those kind of things you can decide accordingly. Okay, so here you can see as per this explanation, this density level A is for the low density product application and density level C is for the high component density, like for example portable device, this kind of application. Okay, for more information you can refer IPC 7351, the generic requirements for the surface mount design and land pattern standard. This is a very useful document. If you have time you can go through this document. I hope this video is useful for you. If you like the content, please like and subscribe and please support my channel. Thank you for watching.